All right, I decided to make one more video. I want to talk through how to answer um, some of these correlation and regression questions in MyOpenMath because they can be a little bit tricky. And so I'm going to make a video where I talk through question 16, and you can use that as a template to help you with your homework. So question 16 says, a study was done to look at the relationship between the number of movies people watch at the theater each year and the number of books that they read each year. The results of the survey are shown below. We're going to find out the correlation coefficient, the multiple R squared, the regression line, and do some interpretation. So there's a couple subtleties in here that, to be honest, don't quite match my earlier lecture video. So I'm going to highlight those. First thing we need to do is get our data into R so that we can do our correlation tests and our regression tests. You can just copy and paste the data in, but you have to make sure you put commas between the numbers, except the last number should have a parentheses after it. So let's copy the movies and books. I did it earlier with another question. That's why you're seeing some things in here already. Oops. All right, now the first thing I would do before even answer this question, assuming that you're using R and RStudio to do this work, is to visualize the data, because that will help you keep track of whether or not your answers make sense. So let's read in the data and then let's graph it. All right, so it looks like there's a kind of a negative trend going on here, that people who watch more movies tend to also read fewer books. When you visualize, you should always put the independent variable first. Now we can start the question. They want to know the correlation coefficient for this sample R. And our correlation coefficient is negative 0.865. Like we said, it's a pretty strong or a moderately strong negative correlation. And they just want two decimal places, so let's do negative 0.87. All right, here's the first place where my previous lecture video didn't quite capture everything. I told you that the correlation coefficient is R. That's for a sample. Populations also have correlation coefficients, and they use the Greek letter. Correlation coefficients use the Greek letter rho, which is the Greek letter for R, but unfortunately, it looks an awful lot like the Roman letter P. What did I do? Here we go. So rho looks like a lowercase p. This is not P, this is rho. So you won't see me ever asking you to interpret Greek letters. I'm going to use words like population correlation coefficient, or at the very least, I'm going to use the phonetic spelling as opposed to the Greek letter. But for this homework, our null hypothesis is that the population correlation coefficient is 0, and our alternative hypothesis is that the population correlation coefficient rho is not 0. Now, we did the correlation test on the movies and books, which reports a p-value for us to use. Now we can put that p-value in, and we're rounding it to 4 decimal places. That is a very small p-value, smaller than our significance level. So our correlation coefficient is significantly different from 0, which is the answer we want to pick is there is statistically significant evidence to conclude that there is a correlation between the number of movies watched per year and the number of books read per year. Boom. We might want to conclude that a person who watches more movies will watch fewer books than a person who watches fewer movies. That might generally be the right trend, but as we can see from our picture, that's not always the case. Here is someone who watched 5 movies and read 2 books. Here's someone who watched 5 movies and read 5 books. So the correlation coefficient does not guarantee that more movies equals fewer books. It means that there is a statistically significant trend between them. All right, now that we've done our correlation analysis, let's move on to our regression analysis. So we're going to do a linear model. I'm going to call it lm.movies. And here you want to put the dependent variable first. So we want to put books, then tilde, then movies. Run that code, look at the summary, and here's our output. We have an intercept, and we have a slope. The p-value on our slope is statistically significant because it's very small. And here's our r-squared, 0.7484. So we can put that in there, round to 2 decimal places, so we round up to 0.75. That tells us that 75% of the variation is explained by the number of movies. So if you know how many movies someone watches, the variation is reduced by 75%. All right, now let's put in the equation of the regression line. And here is another difference. I'm going to copy and paste this into the lecture notes. In my open math, the equation of the regression line, aka line of best fit, is written backwards. It is written y equals b plus m times x instead of y equals mx plus b. So the first box is for the estimate of the intercept. The second box is for the estimate of the slope. So our intercept has an estimate of 5.75, and our slope has an estimate of negative 0.64. And now we can use the model to predict the number of books read each year if someone watched 8 movies. So we come over here to R, and we use a 5.75 or 5.7477 minus 0.6424 times the 8 movies, and we're going to predict that they read 0.6 books. But we're going to round it to the nearest whole number, so we're going to predict that they make it through 1 book. Now, interpreting this slope of negative 0.64, it does mean that as x goes up, y goes down, but we can get a little bit more information. For every additional movie that people watch each year, there tends to be an average decrease of 0.64 books being read. And our y-intercept says the best prediction for a person who doesn't watch any movies is that they will read 5.75 or 6 books each year. So this is rounding up the intercept from part F. I might want to answer if someone watches 0 movies per year, then that person will read 6 books this year. That makes sense, but remember, this is a prediction. We don't know for sure that they'll read 6 books. We simply predict that they'll read 6 books. There we go. All right, so hopefully this walkthrough will be helpful as you tackle your homework. That is the end of this last short video and probably the end of lecture videos for the term. So thank you very much for watching.